Ahmed Youssef from Nodelbrog. In this short video, we will go through the maintenance process of Postgres using pgadmin4. We are going to log into our database, to the server, and then we will check how can we monitor the health of a specific table, how can we enhance how this table actually is working. So let's select one of our databases. Let's select this DB, which is DemoDB. Inside this DemoDB, we have inside this schema, which is public, we have already created that table, which is products. This product table simply contains two columns, which is ID for the product, and the type of ID is sequence, and we have a product name, which is character varying. What we are going to see, let's first check what are the data that we have. So yeah, basically we have two main records. As you might know, in PostgreSQL, we have the major part of the maintenance is about keeping sure that only the shown records that are called live records are stored on the file system. The point is you might have a table with 100 records, but on the hard disk, on the file system, you might have 120 records. Why this is happening? This happens because by default, when you delete a record from a table, this record is not removed from the hard disk at once. It is just kept and flagged that this is a dead record. This actually makes the process more faster, and even it makes Postgres available and capable of handling multi-version concurrent connection, or the concept of MVCC that we have talked about earlier. So let's see how this actually works. Let's add a new product. Let's say you will be adding Galaxy Note as product, Galaxy Note 20. This is our new product, and let's save. Now we have those three products. In order to see how many records are actually stored on the file system, we are going to use that command, which is called analyze. So I'm going to open the query tool, and I will execute this command, which is analyze, and table name, which is products. I will execute the query. Okay. Verbose actually gives us more information, and this is what we need to know. Okay, so okay, so analysis have been executed against that table within this schema, and it's telling me that it found only one page. The table is containing only one page, and it has 3 live rows and 0 dead rows. And this is the interesting part. This is the point that we are looking for. We need to check while we are maintaining the table that the number of live records are actually equal to the total record that we can see, and we don't have any dead rows. Let's now see what would happen if we deleted one of the rows. Let's say that iPhone 11 is getting a little bit old. I will be selecting that row, I will be deleting that row, and I will be saving. So now it's gone. It seems to be gone. Let's get back to the query tool, and let's run the same query again. Analyze verbose products. Interesting. Now we got that the table contained 2 live rows, and this is what we expected, and it contains another one dead row, which represents the row that we have just removed. So now how can we get rid of this dead row? Simply we have this operation, which is called vacuum. So if I say vacuum products, this means get rid of all the dead rows. I cannot run vacuum within this query, so I will be selecting this statement. So when I execute this statement, only will be executed, which is vacuum products. Vacuum, I'm sorry, products. Okay. So vacuum products, yes, vacuum operation is successful. We need to run the analyze variables one more time. Let's select it and let's execute. Now we have two live rows and zero dead rows. So actually the row that we have maintained, or the database was maintaining on the file system, it's already gone, and this is what we needed to do. Let's see as well what's going to happen on the other scenario if we selected to update a row instead of removing it. So now I'm going to update that row to make this product Galaxy Note 20 Ultra. Now that row is updated, I'm going to save, and let's see what's going to happen if we get back to the query tool and we try to execute the analyze variables product. Yes, we have two live rows and zero dead row. And in order to understand this, this is telling us the update process actually is not update in place. So if you are going to update a specific record, Postgres actually duplicates that record and deletes the previous one and put the new value to the new one. So after the update process, actually you still have one dead row left, even if you didn't update it, or even if you are not using it, but actually it's there. How can we get rid of that dead row? In the same way, we are going to select the vacuum process. We are going to execute vacuum. I'm going to select it first. Yes, I'm going to execute vacuum, and now we are going to check. And now we have no dead rows. Interesting. So now our database is not keeping tracking of those data. One more thing, or one last thing we need to keep in mind while we are thinking about the maintenance of a specific table and the vacuum process, which is another interesting command called vacuum full. What does vacuum full do? In order to understand what vacuum full do, we need to dive deep into vacuum first. Vacuum actually did not remove the file or did not remove the record completely from the hard disk either. So it stopped the database of tracking that record. So now it's not seen to the database. It's not within the records of the database, but it's still on the hard disk. Why this is happening? Why vacuum didn't go to the hard disk and remove the data at once? The point is, if the command is going to remove the record from the file system, this will rearrange how the table is actually written on the hard disk, which means that that operation would be table locking operation. It would require table locking operation. And this is what happened actually for vacuum full. So vacuum full goes, it removes the record from the database. It's not tracked by the database, and it's got removed as well from the file system. And in order to do this vacuum full operation, we have a lock on the table, which means that no one will be able to update or delete any records as long as this vacuum full process is happening. That's why we have that more light operation, which is vacuum, which gives us a good advantage of making the database ignore the records that actually are dead records, is not making the database server busy. They are not being tracked of the database server, and in the same time, it does not cost us any time where the table is locked. So basically how we use vacuum and vacuum full, we usually use vacuum in short term. So we usually, in a repetitive way, we use vacuum, and we use vacuum full only to reclaim hard disk space when we need it. So we use vacuum full on larger cycles of maintenance. So on short term maintenance cycles, it's fine to use vacuum. On a long term maintenance process, we use vacuum full. So that was all about analyze, vacuum, vacuum full. We learned how the database actually is dealing with the update and the delete process. Hope you find this video useful. Thank you so much and looking forward to seeing you in upcoming videos. Thank you so much.